Morning, everyone. My name is Marian Grace Vasquez, and I am your seventh reporter for this subject. My topic is all about solar radiation and Earth energy balance. First is solar radiation. Solar radiation, often called the solar resource or just sunlight. It is a general term for an electromagnetic radiation emitted by the sun. Solar radiation can be captured and turned into useful form of energy such as heat and electricity using a variety of technologies. However, the technical feasibility and economical operation of these technologies at a specific location depend on the available solar resource. There are three things happen to sun's energy when it enters Earth's surface. It absorbs, reflects, and scattered. First is absorption. Absorption is different from scattering and reflection because absorption involves more than a change in the direction of the radiation. Absorption of radiation involves the conversion of electromagnetic radiation into heat. Next is reflection. Reflection of solar radiation occurs when the radiation is sent directly backward from the surface. The fraction or the percentage of the radiation reflect back is known as the albedo. Albedo varies directly or greatly from one direction to another on Earth, depending on the type of surface, for example, the land or the water, the extent of snow or vegetation coverage, and the angle of incoming solar radiation. Glacier and ice sheet have high albedos, reflecting 80 to 90% of radiations reaching their surfaces. The albedo of clouds varies depending on their thickness, with an average albedo of 55%. Water reflects the small amount of solar radiation. Scattering. Scattering of solar radiation occurs when the radiation strikes very small objects in Earth's atmosphere, such as the air molecules, tiny water droplets, ice crystals, or aerosol, which disperse the solar radiation in all directions. Air molecules and aerosols scattered solar radiation in the atmosphere. Air molecules are much smaller than the wavelength of visible light striking them. Therefore, more of the blue shorter wavelength of light are scattered than the red longer wavelength of light. This is the reason why the sky appears blue during daytime. Water droplets and ice crystals that make up clouds scattered light equally at all wavelengths and therefore appears white. Next is solar radiation is divided into two parts, which is the 70% of the solar radiation reaches the Earth's surface and the 30% reflected back to the space by clouds, particles on atmosphere, or snow, sand, and concrete. This picture shows the enumeration or the division of the 100% solar radiation comes from the sun, and that 70% is also divided into two, which is 51% absorbed by the Earth's surface, 19% absorbed by the atmosphere by the clouds. Also, for the 30%, it is divided into three, which is 4% reflected by the surface or reflected from surface, 20% is reflected from or by clouds, 6% is reflected by atmosphere. These 6% are the one who scattered in the atmosphere. So of that 70% energy, 1/3 of it powers the hydrologic cycle, and 2/3 of it warms the atmosphere, oceans, or the continents and lands. When UV radiation hits Earth's surface, it is converted into infrared heat, which in this picture it shows the greenhouse effect and shows the travel of the sunlight or the solar radiation, and explains that some sunlight that hits the earth is reflected and some become heats, and it is the carbon dioxide and the other gases in the atmosphere's job to trap the heat to keep the earth warm. So next is the earth energy balance. You have learned that the earth's surface absorbs and emits radiation at the same rate. This balance in rate of earth absorption and emission occurs at 255 Kelvin or negative 18 degrees Celsius or 0 degree Fahrenheit. But Earth average temperature is actually much warmer, which is 288 Kelvin. That is 15 degrees Celsius or 59 degree Fahrenheit. The difference can be explained when you take into consideration the atmosphere. Even though Earth's atmosphere absorbs and emits infrared radiation, it does not absorb and emit equally. Certain gases in the atmosphere absorb some wavelength and radiation. It actually transfers their energy into heat, while other gases are transparent and they allow radiation to pass through them freely without absorption taking place. So this is the diagram of the Earth energy balance, and it shows here the process of the incoming solar radiation and how it reflected back to our space. That not the whole amount of energy is actually absorbed by our Earth's surface. Some of it is reflected from the surface, reflected by the atmosphere, and reflected by the clouds. So the 6% of the reflected by the atmosphere is those are the energy that's scattered on our atmosphere, or the carbon dioxide and the other gases do their job to trap the heats to still keep the earth warm. Next is the explanation of the energies or of the earth energy balance. But basically, the main concept of the earth energy balance is that the energy that comes in is actually equal to the energy that comes out. So in this picture, it shows that the energy entering the top of the atmosphere is equal to the energy leaving the top of the atmosphere. And that is, as we can see in this picture, the incoming solar radiation is equal to 342 units. And in the both end of this picture, we can see that there is 107 reflected solar radiation and a 235 outgoing long-wave radiation. If we sum up the 107 and the 235, that would equal to 342. And in that case, there is a balance. And on the next situation, energy gained by the atmosphere is equal to energy lost by atmosphere. Energy gained by atmosphere is equal to 67 unit absorbed by the atmosphere, the 350, which is the surface radiation, the 78 unit, which is the latent heat, and also the 24 unit, which is the thermal energy. Then that is equal to energy lost by atmosphere, which is emitted by atmosphere energy, the 165, The 324 is the back radiation, and the 30 is actually also emitted by the atmosphere. So again, that is equal to the energy gained by the atmosphere. And the next example is for the energy entering the surface is equal to energy leaving the Earth's surface. So if we sum up all the energy under the energy entering the surface, Earth's surface, and we equate it to energy leaving the Earth's surface, the answer would be equal. So the overall energy balance of the Earth is influenced by the reflective property of the atmosphere and the surface albedo, as well by the ability of atmosphere component to interact with infrared radiation emitted from Earth's surface, or the greenhouse effect, with both processes being strongly coupled. So to sum it up, all the energy that the sun gives up, it goes directly to our Earth surface, but it is divided into two because the 70% of it goes to our Earth surface or absorbed by the Earth surface, and the 30% of it is reflected back to our space. And also, for us to achieve the average temperature of our planet, we have to balance the energy coming in that comes from the sun, and we let some of the energy back to the atmosphere. And the process has to be balanced carefully in order to get the average temperature for us to be, or for us to have a stable weather or stable season. So again, guys, be responsible for the things you do because some of it may affect our greenhouse effect, and also it may harm our planet. And again, that would be all. Thank you.